Today we want to talk about solving systems of equations. The two main methods we use to solve systems of equations is substitution and elimination. First we'll look at substitution. As the name suggests, we want to substitute something in for something else. If we look at our example here, we can see that it would be very simple for us to solve this bottom equation for y. We subtract 2x from both sides, and we get that y is equal to 9 minus 2x. And here's where the substitution comes in. Since we know what y is, we can plug in for the y in the first equation. This will give us 3 times 9 minus 2x minus 2x is equal to 11. Now we distribute our 3 and we get 27 minus 6x minus 2x is equal to 11. We combine like terms, we get 27 minus 8x is equal to 11. Subtract 27 from both sides, and we get negative 8x is equal to negative 16. We divide by negative 8x, or negative 8, so that we can solve for x, and we get that x is equal to 2. Now good, we found half of our solution. We found our x value. Now we want to go back and we can either put our x into our first equation here, and we can solve for y. We can plug in x into this equation and solve for y. Or, since the common theme seems to be that we need to solve for y, why don't we just plug x in where we've already solved for y? So, if we get this, we'll get y is equal to 9 minus 2 times 2, and y is equal to 9 minus 4, or y is equal to 5. Now good, we've got our solution. X is equal to 2, y is equal to 5. However, we can't just leave it like this. When we're solving systems of equation, we need to write this as an ordered pair. So, we write x comma y, or 2 comma 5, and this is our final solution. Always remember to put it in an ordered pair, and don't just leave it as x equals and y equals. Our next example, we want to find a solution using elimination. Now when we eliminate, we want to be able to add the equations together and eliminate one of the variables. That's why we call it elimination. In our example, it would see that if we added these two equations together, the negative 2x and the plus 2x would cancel out. So let's do that and see what happens. We add these together, and we get 4y is equal to 20. Notice when we added, the negative 2x and the plus 2x canceled out. Now we solve for y. We divide by 4 on both sides, and we get y is equal to 5. Just like we did before, we can substitute our solution for y back into one of the equations. I'm going to pick the second one. So this is going to give me 5 plus 2x is equal to 9. We subtract 5 from both sides, and we get 2x is equal to 4. We divide by 2, and we get that x is equal to 2. As before, we can't leave it like this, so we write it as an ordered pair. We write 2, 5, and that's the solution we're looking for. Now, when it comes to systems of equations, we have some terminology that we use to describe them. If we say something is consistent, that means that there is at least one solution to the system of equations. When the system of equations intersects in one point, like it does right here, that is one solution. However, what if the two lines happen to lie on top of each other? Well, then they would be the same line, and instead of meeting in one spot, then they would meet in an infinite number of spots. This too would be considered a consistent equation. And that is why we say that there exists at least one solution. You can either have one or you can have infinite. Now, what if you don't have one? Well, that is what we call inconsistent. And this is going to come from parallel lines because they never intersect. Now, if we're looking at a consistent system, we can use one of two words to describe them. We can use independent or independent. But remember, first, it needs to be consistent. So independent, there exists exactly one solution to the system of equations. Going back to our picture here, we've got that point of intersection. That's exactly one solution. This is independent. Now, if there exists an infinite number of solutions to the system of equations, as I said before, the two lines are going to line up on top of each other. And so, this is going to be dependent. So, let's take a look at some examples, so hopefully we can get a better understanding of what we're talking about here. So solve the following system of equations, and then determine the type of system. Well, this first equation here looks pretty simple to solve for x. We get x is equal to y plus 6, and now we plug it in to our second equation, which will give us negative 2 times y plus 6 plus 2y is equal to 1. We distribute our negative 2 and we get negative 2y minus 12 plus 2y is equal to 1. Now, we collect our like terms, but when we do that, we see that negative 2y plus 2y is going to give us 0y, so we're just left with negative 12 is equal to 1. Now, hopefully most of you are saying that is complete nonsense and that doesn't make any sense. Negative 12 doesn't equal 1, negative 12 equals negative 12, and 1 equals 1. Well, this is the kind of nonsensical work that you will come to realize is an inconsistent equation. This never holds. Negative 12 will never equal negative 1. Now, let's take a look at one more example. Solve the following systems of equations and then determine the type of system that it is. Well, okay. This looks like a good case for elimination for the simple fact that all we have to do is multiply this top one by 5 and we can get our x's to be eliminated. This will give us 10x plus 25y is equal to negative 5. We keep our bottom equation the same. We get negative 10x minus 25y is equal to 5. Once again, we add them together. Our x's canceled out just like we wanted. But when we go to add our y's together, that also cancels out. So that's kind of weird that both of those are gone now. So we're left with 0 on our left-hand side. We add our right-hand side, negative 5 plus 5. That doesn't equal 5. That, in fact, equals 0. Well, that's kind of weird. That doesn't look like our previous example where we had something that was completely ridiculous. 0 does equal 0. So I wonder what this means. So let's solve for our x and our y intercepts and see if we can plot these two equations and see what's going on here. If we look at 2x plus 5y equals negative 1. If we let x equals 0, we can see that our y-intercept is going to equal negative 1/5. And if we let y equal 0, we can see that our x-intercept equals negative 1/2. Okay, well that doesn't seem so out of the ordinary. We can plot these. And since we've got our 2 points, we can draw a line. Let's change color here and let's see what we can get when we plot our other one. If we let x equal 0, our y-intercept is going to equal negative 1/5. Well, that's kind of weird. That's the same one. Let's find our x-intercept. We let y equal 0. Our x-intercept well, that equals negative 1/2. Well, that's kind of weird. Plot those. And now that we've got our points, we can draw our line. But since they have the same x and y intercept, then those two lines must be the same. So this is what we call consistent and this is going to be dependent. Now notice that when it's consistent, we can either be independent or dependent, but when it was inconsistent, we just left it. Once you know that the system is inconsistent, we just leave it and we move on. If it's consistent, then we have to decide whether it is dependent or independent. All right, hopefully this helped you guys, and hopefully you know a little more about solving systems of equations.